5 of them, alright? So it's 5 of them to do both the full structure and the condensed structure of the formula, alright? So 2 things they have to do. So it's in other words, they're going to need 2 answers for each of them, alright? Following?
Mm-hmm.
And this one now is going to be structure and condensed. Want me to do the first one for you? So pentane, so the full structure. So pent 1, 2, 3, 4, 5 branches at the second position, see? Remember that each carbon atom must have 4 bonds. So after you draw a skeleton with carbons, you need to fill up the hydrogens. That's a good way of practicing to do it. Alright? Then for the full structure, so CH3. On papers, alright? But you'll have an idea from last week the answers to the questions. Alright, so moving on. So that's the answer for A. B23 dimethyl, so pentanes at all times of the drawing the structure will go 1, 2, 3, 4, 5. So we'll go for the longest chain first. So we'll look at the last part of the name for the longest chain. And we have 2 methyl group, they are position 2 and 3. Alright? So one will be there, another one there. Alright? Sometimes you can actually partially condense this, but I'm not going to teach you that today. Alright? So practice to do the full structure, but actually we can actually condense them a little bit. That's it. Alright? Then so the full structure, and then condense is CH2. I'm just going to write it below. I'm going to need lots of space, alright? So this is CH3, CH2, it has a branch, CH3 in bracket, has another CH here. Sorry, this is just a CH there, my bad. CH. Following, this one that is attached to have only 1 hydrogen. So it's a CH here and a CH3. Another CH in bracket again, CH3. And CH2, CH3. That's for B. For C, it's a pentane. 1, 2, 3, 4, 5. 3, 3 diameter. So 1, 2, 3. So it's 1, 2, 3, 4, 5. So if it is 3, 3, then it simply means that we have a CH3 here. We also have another CH3 here. So if you notice, whenever we are drawing structures from the name, we draw the longest chain first. So we just look at the last part of the name to see how many carbon atoms in the longest chain. Then we number it, and then we will add the methyl group or the alkyl groups based on the carbon atom that is in the longest chain. Right? Structure for this, and CH3, CH2, then this is a C, sorry, I didn't finish this one. H. So remember, at all times you should have all the carbon atoms have all the hydrogens next to it. I want to give you D and E for your homework, so you get to practice on your own, alright? Because in terms of the time constraint, I want to move into naming the alkenes now. But I want to keep it simple. I'm not going to go into any complex isomerism and long chain for those, alright? Because whenever we're doing these complex long chain in the exam, most likely it's alkane they're going to give you. Or the alkenes and the alcohol. It's just that they want the additional concept that they can move the functional group around. It's not just the branches. Alright? So, unlike in alkanes where the isomers comes from just branching the chain, for alkenes it can also come from not just branching long chains, but also can be by moving the position of the double bonds. Alright? So alkenes, so the general formula CnH2n, functional group. So this is the second member of the homologous series. It's another homologous series, alright? So the first one was alkanes that we just discussed. This one is alkenes. Functional group C double bond C. So remember that naming is similar. So if, for example, we have C, remember that each carbon atom must have 4 bonds. So how many hydrogen atoms would be required in this carbon to have 4 bonds? 1. Because they have 1, 2, 3, 4. This one, 1, 2, 3, 4. This carbon atom, 1, 2, 3, 4. Following? And this is alkenes, the functional group double bond, right? And the name for this molecule is pro 3 carbon atoms E. Alright? So structural by 1 branching long chain, just like in the alkenes, but also moving position of double bond. Now, example here. Next we have So this is 1 butene. We indicate the 1 here in this case, the position of the double bond. So when we are counting the position in alkenes now, it's not the carbon atom, but it's actually the first bond between the carbon atoms. So you have to make note of that. So this number in alkenes now, it's for the long chain, it's the bond between the carbon atoms to start the number. So this will be bond 1, 2, 3 to get this number. Alright? So we could move the double bond and put here, if we want an additional isomer of butene, to say 2 butene. Right? And 2 butene would be just simple this. Put in the double bond here. You see? So this is 2 butene. Alright? So in addition to this concept, we can still go back and like mix it with the branch molecules to name it. Alright? And then also now use the one, so a complex one, 4, 5. Now, this is the bulky example now, the name of this compound. As you can see here, we have the functional group, which is an alkene, and we have a branch. Remember that when we are talking about alkanes, the branch always take preference for the lowest number. When we have a functional group, such as in the alkenes or the alcohol or the carboxylic acid, it's the homologous series functional group that takes the preference for the lowest number. So in this case, because it's an alkene, the one is 1, 2, 3, 4, 5. Alright? So the name of this, just as in the alkanes, we're going to name the branch aspect first. So in this case, it's going to be 4 methyl, longest one is 1, 2, 3, 4, 5, but it's 1 pentene. So we still have to put this 1 here indicating where the double bond is. So this 4 is indicating where the branch is, this one is indicating where the double bond is. Following? So remember that this 1 here is actually indicating the first bond between carbon-carbon atoms, where the double bond is. Clear? So if I want to make things more complex, moving the position, put 2s in. The position of the double bond as the means of doing the structural isomer, right? I can put the double bond here to form another isomer of this. So one isomer of this compound is C. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Hydrogen here or not? Yes or no?
1.
How many hydrogens here?
1.
How many here?
3.
Good. You following Mr. Hardy? The number that should be there? Because each carbon atom must have 4 bonds.
I'm going to tell you what that. Just before that.
Yes?
Yeah, just it.
Alright. So the name of this node 1, 2, 3, 1, 2. So we still have the name from this side Y. We still have to number the carbon atoms from this side. Why is that so? Because the functional group takes preference, and in this position it's 1, 2, lowest number. If we should, no, wrong. If we should put it over here, if we should number it from here, it would be 1, 2, 3. Following? So here it's 1, 2, so that it would be 2 pentene as the last part of the name. What will be the first part of the name? Still 4, 2 pentene, right? And it's an isomer. So both these compounds are isomer. Why 4? Because the group, the branch is on carbon number 4. Right, so take this from the board and I'll introduce alcohols and carboxylic acid. Then call it a day, right? So remember that the same concept that we use for alkanes with naming is the same concept that they're going to use to the alkenes, the alcohol, and the carboxylic acid in terms of the branch. It's just the last part of the name would be different.